The ellipse, take 3. Yes, this is the third time I'm recording this wonderful video. Hello there, this is Ms. Nakayama. Today's lesson starts out our chapter on conic sections. This is 9.1, the ellipse. And in this video, I'm going to cover graphing ellipses at the origin and away from the origin, writing equations of ellipses, and solving applied problems. So, first and foremost, what is the definition of an ellipse? An ellipse is the set of all points P in a plane such that the sum of those distances from two fixed points is a constant. Okay? This definition, to me, if you understand this, will make life easier for you. So, I'm going to show you a diagram. I said it was the set of all points, okay, from two fixed points. So I have a fixed point here and a fixed point there. It doesn't matter where they are. They don't move, okay? And then I have this string, if you think about it. I put a string around a pin, and if I take the string and wrap it around the pin and go to this other point, and I add up the distance from the pin to the fixed point and the pin to this fixed point, that's the length of that string, which in this case is 16. And as you see, as I move my pen around, the length of my string never changes. It's always 16. And my pen is on this blue curve. This blue curve is an ellipse because it is the set of all points such that the sum of the distance from two fixed points is always a constant. That's an ellipse. Those two fixed points have a special name. They are called the foci. That is plural of focus. And the midpoint between any two foci is the ellipse. The center of the ellipse. Okay, so our ellipse can be either horizontal or vertical. And for some reason, it doesn't want to stop at a nice place. So let's try again. All right, so I have a vertical ellipse and I have a horizontal ellipse. Either way, there will be a major axis and a minor axis. And just like you think, that major axis is going to be the longer one, either way, horizontal or vertical. The minor axis will be the shorter one in both cases, and the center is going to be the intersection of the major and the minor axis. And what you always need to remember is that at the endpoints of the major axis, you can find the vertices. Singular is vertex. So that's a vertex at the endpoint of each major axis. Okay? So the standard form of the equation that you need to know looks like this. This is centered at the origin, like this picture suggests. Okay? And this is a horizontal ellipse. This is a vertical ellipse. Its equation is very similar. And if you notice, what is different, X and Y are still in the same order, but A and B got switched. And that's because in the horizontal ellipse, A is on the X-axis in this case, and in the vertical, A is on the Y-axis. And what's more important is, as I kind of talked to you before, A, and this is something you really need to know, A is the distance from the center to the vertex. Okay? B is the distance from the center to the covertex. This is a vertex. This is a vertex. This is often referred to as a covertex and a covertex. And C is the distance from the center to a focus in either direction. Okay? Now, if A is the endpoint of a major axis, then you should know that A is always going to be larger than B. So you can look at this equation and know it's a horizontal one because the bigger number's under the X. The bigger number's under the Y, it's going to be a vertical ellipse. Okay? Because A is the distance from the center to the vertex, then you know that the major axis has to be 2A units long, and the minor axis will be 2B units long. So the other thing that you need to know about this A, B, and C is the relationship between all three of them, and that is that C squared equals A squared minus B squared. So let's see what you got to be able to do. First, graph an ellipse centered at the origin. Well, before you graph that, y'all, you want to remember that in standard form, it was always equal to 1. So the first thing I'm going to do is put this in standard form by dividing each term by 144. And when I do, I get x squared over 9 plus y squared over 16 is equal to 1. And that puts my center at the origin. And underneath my x squared is 9. Take the square root of 9 and you get 3. So in the x direction, which is left and right, I'm going to go right 3 and left 3. And underneath my y is 16. Square root of 16 is 4. So I'm going to go up 4 and down 4. And obviously 4 is bigger than 3, so up and down is those are the vertices of my ellipse. And now I'm going to do my best to try to use this graphing tool. Whatever. There we go. It's not too bad. Okay. To graph my ellipse. Now, y'all, you're going to have to at some point name the vertices and co-vertices. And I promise you, it is much easier if you graph it first and know that the endpoints of the longer one are always the vertices and the shorter ones are the co-vertices. Now, we also have to go find the foci. So our foci, how do we find that? We use that equation of c squared equals a squared minus b squared. Y'all, you have a squared and b squared right here. And when you subtract, a is always larger than b. So just take the larger one and subtract the smaller one. So c squared equals 16 minus 9, c squared equals 7, and c equals plus or minus the square root of 7. Now that is somewhere between 2 and 3. You can get your calculator out and look if you want to, but I want to go plot this. The key of where it is that it has to be on the same axis with your vertices. So that means I'm going to go up and down between 2 and 3. Okay, and those are my foci. As if I had to name them, I would say 0, comma, plus or minus the square root of 7. But it's easy to tell if you will graph it and you don't get mixed up on some little simple things. Okay, let's go to example number 2. This time we're going to go backwards. And that is we're going to go find the standard form of the equation from a graph or from information given. So the information given here, I'm going to go ahead and plot it because I'm a big fan of pictures and being able to solve a problem. First and foremost, we want to know that halfway between, well, let's label these points. So first off, I have a focus here and a focus here and a vertex there and a vertex. So those are each of those. And halfway between the foci or halfway between the vertices, I know I have my center. My center is at the origin, and that means that I can go ahead and set up my equation. X squared over something plus y squared over something equals 1. I need to remember the vertices. The distance from the center to the vertex is a, and I moved left and right, so a squared is going to go under the variable that goes left and right, which is x. 3 squared is 9. Now I have to find y. In my picture, I didn't go up and down. I only went left and right, but I know the focus, and the focus represents the letter C, and so C is 2. So I get to use my equation. C squared equals a squared minus b squared. C squared is 4. A squared is 9, so I'm 9 minus b squared, and that gets b squared to be 5, which is what I need right here, and that is my equation. All right. Next, we move them off of the origin. Y'all have done this. We've been doing this all year. H and K tell us that horizontal and vertical movement from the origin. Okay? H is always with X. K is always with Y. Your center is HK. And again, it doesn't matter if it's a horizontal or a vertical ellipse. H is always with X. K is always with Y. You can copy these down if you want to, y'all, but I promise you it's easier if you graph it and just get the coordinates off the graph. So I'm going to do this one real quick. Graphing an ellipse centered at HK. So x plus 1 quantity squared over 9 plus y minus 2 quantities squared over 4 equals 1. Okay, it's always the opposite of what it looks like in the parentheses because it was x minus h and y plus k. So my center is going to be negative 1, 2. So I'm going to go left 1 up 2, and that is not what I want to use, so I need to change. Left 1 up 2. And now underneath my x is a 9. Square root of 9 is 3. X moves left and right. 1, 2, 3 to the right. 1, 2, 3 to the left. Underneath my y is 4. Square root of 4 is 2. So from my center, I'm going to go down 2, and I'm going to go up 2. And then I'm going to graph it. Now, as I'm doing this, you should try to know what your what do you call it? Which one's going to be your vertices? Which one is going to be your co-vertices? Your vertices are always at the longer, on the longer axis. So that means that these are my vertices and these are my co-vertices. Okay, we're going to go backwards off of the center. Find the standard form of the equation of ellipse with endpoints of the major axis negative 2, 6, negative 2, 0, and endpoints of the minor axis at 0, 3, and negative 4, 3. So again, I'm going to make a picture. I think it's easiest for a picture. I plotted the points. Okay? The endpoints of the major axis are where my vertices are. How does that happen? I didn't know. Oh, I do know. Okay. So that's a vertex. And up here is a vertex. And I'm probably going to mess it up again anyway. All right. So let's just keep going. So from there, I have my... Okay. So I have up and down is my major axis, and left and right is my minor axis. And where they intersect is the center of my ellipse. So when I set that up, okay, I've centered off of the origin. So I'm going to have plus or minus a number in those parentheses now. X minus a negative 2 is plus 2. Y minus 3 is y minus 3. And from here, okay, how far did I move left and right? From the center to that point was 2 units. So on the x, under the x, I'm going to square 2. And from my center to go up, which, there it is, center up to a vertex is 3. So under my y is going to be 9, which is 3 squared. Okay. Next, you have to be able to convert an equation into standard form. Okay, and you're going to do that with the process of completing the square. So to set that up, we're going to group our x's together and group our y's together and take our 532 to the other side. I also have to factor out that leading coefficient of the squared terms. So it sets up like this. First off, 4 parentheses something plus 36 parentheses something equals negative 532. Okay? Now, when I take the 4 out of x squared, I'm left with x squared. When I take the 4 out of the 40, I'm left with 10x. And then I have plus blank. And I have plus blank on the left. I'm going to have plus blank on the right. Now I'm going to deal with my y's. I'm just setting them up right now. 36 from the 36y squared is going to leave me with y squared. 36 from 288 is negative 8y. And again, plus a blank. And so I'm going to have plus a blank. Now, this, you've got to be very careful, y'all. If you have a number outside here, you got to put the same number over here. So in front of the first one, I've got to put my 4. And in front of the second one, I've got to put my 36. And I can give you some clues of how you can know whether or not you've messed it up. So when I do this completing the square, y'all, I do it to make the next step easier. So if you will do it the same way, the next step will be easier. So to complete the square, you take half of your linear term. That's the one without the exponent. I take half of 10, which of course is 5, and then I square it. 5 squared is 25. Then I'm going to take half of 8. Half of 8 is 4, and I'm going to square it. And 4 squared is 16. Okay? And just to remind you yet again, yes, it's negative 8, but I'm going to square it. And whenever you square a negative number, it's positive. So if you just ignore the negative sign right here, we're not ignoring it in the problem, it will hopefully prevent you from making mistakes. So it's always adding a number in both cases, no matter what. And that number will be positive because you're squaring it. Okay, on the next step, we've got to factor what's in the parentheses. And it's going to be a perfect square. And this is what I'm saying. When you set it up like this, you take something from each term. So from the first term, I'm taking the x without the exponent. And the last term, I'm taking the 5 without the exponent. And the middle term is going to give me my sign. So y squared without the square, 4 squared without the square, the sign of my middle term. And then when I combine negative 532 and 4 times 25 and 36 times 16, I get 144. I have to make it equal to 1, so I'm dividing everything by 144, and that's going to give me x plus 5 quantity squared over 36 plus y minus 4 squared over 4 is equal to 1. So at this step, y'all, more times than not, these two numbers multiplied together will give you that one. And if it doesn't, you probably left off this 436. So try to keep that in mind. The center of this is negative 5, 4. So I'm going to go graph that because I'm going to graph it to find the location of my foci. Some of y'all, well, we have to graph it anyway, but some of y'all might prefer to use the formulas, but I have found people make more mistakes with the formulas than using a picture. So if I go over 5, 1, 2, 3, 4, 5 to the left, 1, 2, 3, 4, up 4. There's my center. Underneath my x is 36, so I'm going to go the square root of 36 is 6 in left and right. So I go right 6, and then I'm going to go left 6. Just puts me off the graph by 1. And underneath my y is 4. Square root of 4 is 2, so I'm going to go up 2 and down 2. And now I'm going to go try to draw a nice little graph. All right, so from here on my graph, it makes more sense to label your vertices and your covertices so you'll always remember what is what. If you have to give those coordinates, you have it. I didn't need a formula to give those coordinates if I know the vocab. So next I've got to go find the foci, which is that wonderful equation of c squared equals a squared minus b squared. Remember, those a squared and b squared are under my equation right there in standard form. Subtract the bigger minus the large, the bigger minus the smaller. So c squared equals 36 minus 4. C squared equals 32, which is plus or minus 4 square roots of 2. Now, that's approximately 5.7. And the reason I'm telling you that is because if I go and plot that, 5.7 is like right there in one direction. That's a focus. And over here in the other direction, that's a focus. And I plotted it because it's a good way to just have an easy check that I've done it correctly, because the focus is always inside the curve. Every conic section we're going to talk about, focus is inside the curve. So how do you write it? Because you have to give an exact number, is that you're adding this value, which of course is 4 square roots of 2. You're adding it and subtracting it to the center. So my x coordinate is changing, not my y coordinate, because I moved left and right. So negative 5 plus or minus 4 square roots of 2, comma 4. It doesn't change because I didn't go up or down. So that is my standard form and finding the foci. Last problem, an application of a truck. Will it fit through the semi-elliptical archway? We have a semi-elliptical archway over a one-way road, has a height of 10 feet and a width of 40 feet. Will a truck that is 12 feet wide and has a height of 9 feet clear the opening of the archway? So one way that we solve these kind of problems is we put them on a coordinate plane. And when we put it on that coordinate plane, we get to center it around the origin, make it symmetric. So my archway, which was 40 feet across, is going to be negative 20 and 20, and it's going to go up to 10. And that's going to allow me to find the equation of that semi-elliptical archway. It is centered at the origin, so I've got x squared plus y squared equals 1. And in the x direction, I went left and right 20. 20 squared is 400. I went up 10 and down 10 if you wanted to, and 10 squared is 100. So that is the equation of this semi-elliptical archway. Now from here, I'm trying to decide if my truck, which is 9 feet tall, it is 12 feet wide, so I'm putting it in the middle, which is going to be the highest spot. So that's going to be negative 6 and 6. And I need to know this spot on my ellipse to see if it's bigger or smaller than 9. So I'm going to plug that in. I'm going to plug in 6 for x squared. That's how I get 36. I don't like my fraction, so I'm going to multiply by 400, which is going to give me 36 plus 4y squared equals 400. Subtract by 36, divide by 4, and take the square root. And the square root of 91 is 9.54, which is greater than 9, and therefore the truck will clear the opening. So that is the end of the ellipse. Let's pray and hope that it all gets uploaded successfully. Thank you so much for watching, and y'all have a great day.